Hey, good morning, everybody. How you doing today? Happy Thursday. Alrighty. There we go. Oh, that was a little fast. That's okay. Next time. Take it a little slower next time. Alright, we got a couple things today. First, we're going to talk about the lab. This was lab 2 for file I/O. Hey, good morning, 404. So we'll talk about the lab 2 assignment 13. That's a little less than I was hoping people would turn it in. Again, do turn things in if you're only partway done. That's okay. Partial credit's fine. Generally, I'm generous about that. Yeah, Mike, it'll be every day. We'll have a lab due. So if you miss one, don't worry too much about it. It's not the biggest deal. Let's see here. Where am I going? There we go. Alright, so we'll work on the lab here, and then we're going to come back and talk more about classes, and then I think we should be able to get into inheritance from Chapter 8 as well. So we'll finish up Chapter 7 and get into Chapter 8, and we'll see how far that goes for us. First, the coffee. So I got another pot going downstairs. Super excited about that. Alright, so for this lab, we're going to let the user make a shopping list in a loop, allow them to enter an item and a quantity. They can keep on going until they're done. So a nice little value with a sentinel loop that says, okay, whenever you're done, you tell me. And then we're going to save all the items and quantities in a binary file. Either we can do it one at a time or just write them all at the end, whichever way you wanted to go about it. So if you don't want to have to save all these things in an array list and then write them, we could just write them one at a time. And that's probably easier. So, hey, Shady Crows. Did I get that right? Good morning. And then just when we're done, we're just going to go read out the list. So just show them that they can close the file, open it, and read it again here. So we're going to do this always in pairs here, the string and then the quantity. Or if we know the number here, we could loop that many times. So I guess that's the advantage of writing them just at the end. Like one of the examples we did, we said, okay, this is the number of numbers that I'm going to write, some random number of numbers, so you know how many to go read. In our case, this is just a set of pairs here, so we don't really need to know that much about it. So I think I remembered to open NetBeans before we started, although now it's not flipping. That's disconcerting. There it goes. Oh, there. No. Yep. NetBeans. There we go. All right, so start a new project. This was Lab 2, a Java application, Java with Ant. Lab 2, I'm going to make sure I put this in the correct Git repository here. So 2151. Winter 2022, and we should be good to go. Let's let that get made here. And you know what? Let's actually, I'm going to go to the course repo here because I think it'll be a little easier if I just copy paste some stuff to start. So we're going to go to our file IO examples. We'll go to source file IO examples, file IO examples.java, and now file IO means nothing here. But when we want to go look to doing binary files, right? We made a file. Here, so let me zoom in a little bit here. Enhance. I love that. Right? We'll go. Oh, this one was reading, so this one was the writing file here. Right here. So we're going to make a data output stream, given a buffered output stream, given a file output stream. Goodness. Then we write a bunch of things here, and we close it. So we always open a file, we read or write the file, and then we close the file. We always do those three things. And then to go read the file, we're checking, again, a little quick sanity check. Does the file exist? Then a data input stream, given a buffered input stream, given a file input stream. And we can go and read out the data here. I think we did a similar one. Yeah, this was the same idea for random values. We wrote the number of random values, and then we wrote some UTF, because we're going to use UTF, and then we're going to use integers. So we can read UTF or write UTF, depending on what we're doing here with these ones. So let's grab one of these ones here. How about this one? We'll make some files. We'll try and catch. Let's get rid of some of these here. This way we just don't have to type all of those big long things in advance, right? And then, yeah, it doesn't know about these imports here. So I'm going to do one import here. Okay, it has to scan the project. Come on, there it goes. If you do one import, and then we change this single one to a star, we can import everything from the Java I/O library. Again, we're not doing the writing some sort of values here like that. I'm going to leave just these two here for a second, because this is what we're going to need. So now we can go ask the user. So if we're going to do with some user input, we'll need our scanner. So scanner keyboard equals new scanner, given system in. And then, yeah, let's add our import for scanner. Okay, and then we can say, hey, please enter the name of an item to add to your shopping list. All right, that's a little long. That's okay. So we can tab that or bring that to another line. And then we'll get a string for the name, item name, keyboard next line. Okay, and then we'll tell them, please enter the quantity by. And then we'll have an int for quantity is integer.parseInt of the keyboard.next line. Equals, there we go. Okay, and then we're going to write the item name first. Right, so we're going to do our writing UTF first for item name. And then we're going to write the quantity next. So we're always going to do this in pairs here. And really, we want to keep on doing this over and over and over and over and over again until they want to stop here. So I'm going to say, let's do string for item name equals just an empty string. And we'll say while item name dot equals ignoring case, equals ignoring case. Let's just say stop here. And we'll say not. While it does not equal stop, then we can keep on looping, doing all this here. And so now Java's upset because we've already declared item name, so we just go change it here. So, or stop to be all done. Sure, we could do that. And then I guess we need to then check one more time, right? So if item name, really the same thing here. If item name equals stop, I guess we could just break the loop. That's a little ugly. I don't like breaks. So we'll just say if it does not equal stop, then we'll do these things here. How's that? Maybe it'd be cleaner to do the break, but again, I just try and avoid those if I can help it. Right? So a nice little loop. So we're just going to, until they enter stop, we'll just keep on going. So enter an item or stop. If it's not stop, ask for the quantity, write them both. When we're done, right, when they've entered stop, then we'll close our binary file. Right? Okay. All right. Yeah, a couple more lines of code than I thought it was going to be, but you know, this maybe it doesn't have to be 3 different lines. So, and then I don't know if you actually count any of this stuff up above. So, what's actually inside of here? Someone asked like how many lines of code I thought it was going to be. Okay, and then we'll go do the reading here real quick. We'll go see if the file exists. Go read it out. Close the file when we're done. And this was going to be our, what was it, shopping list? Shopping list.bin? Sure, so we'll call it shopping list.bin. And this was going to be a type of file here. And we've got our data input stream. Oh, we want the version that has the loop. That's right. So we want the version that has this one here. We're not going to read that one out. So as long as there are bytes available for us to read, we can go get the item name. So we'll have a string for item name. Item name equals my binary input dot read UTF. Go read that UTF, and then we'll have an int for quantity is my binary input dot read int. And we're always going to do that in pairs because I know if there's a name, there's a quantity. If there's no more bytes left to read, I can't read any here. And then we're just going to print them both out. So we'll say item name plus, I don't know, plus quantity. How's that look? Okay. All right, so sorry. So 63 total. Give it a little format. Okay. Maybe a little longer here, but, you know, not everything had to be all doubled up, I guess. Like this is kind of one line. My screen's a little small because the font's so large. So, all right, let's give that a run. See if it works for us. All right, so what should we buy? What should we go shopping for? How about coffee? And let's buy like 10 coffees. All right, and let's go buy. How about some tea? Let's buy like 5 teas, and then what else do we need to buy? We should buy some Coke Zero, and let's buy like a dozen Coke Zeros, and we'll just say stop. So we got coffee 10, tea 5, Coke Zero 12. And there should be a file here that if we look at our file view, in our shopping list.bin, again, it's a binary file. It's not really going to open and look pretty at all. If we wanted to, Visual Studio Code has that really cool hex editor view, so we can look at the individual bytes of data in this file here, and maybe we can make some sense of it here. And so yeah, we'll open it anyway. We'll say, yeah, we want to use the hex editor. There's a little plugin. I think I shared the link for that. And we can see, hey, we'll see the letters coffee, we'll see the letters tea, we'll see the letters Coke Zero. So somewhere after coffee here then should be a number, and that should be 4 bytes. So 1, 2, 3, 4 bytes. Here was 10, right? And then notice we have 2 bytes here. This somewhere in here is telling it something about how many characters are in that UTF string. I don't know exactly how it does it here. It's interesting, I'm sure, but we know that it's 4 bytes for our integer, 1, 2, 3, 4. So we had 5 t's, and then there's 2 bytes, and then it can go read the string, and then 4 bytes for that integer. That was 12 Coke Zeros, and then the end of file. File's done. So the little hex editor is kind of fun. So you can kind of peek inside the file and see that there. So I don't know exactly where it's telling it. Is it just 6 letters? Maybe that's all it is. Yeah, it's just telling it it's 6 letters here, right? So it's going to go read 6 letters. And then this is telling it go read 3 letters. And then this was telling it go read 9 letters. Coke space 0. Look at that. Yeah, we found it. So it's the read UTF is really nice about that. It knows, hey, go read these UTF characters here. And it tells you how long it should be, which is pretty cool. Right? And that's the lab. Any thoughts, questions, concerns? Let me post that here to GitHub for you for reference. Again, the goals, I'm going to show you a way. You can read the book to see another way. We'll do a lab to practice something. And then we've got our bigger projects to kind of pull some of these topics together here. So this was 2151. So I got to get rid of some of these old repos here. So let's just remove this. Remove the old ones. Remove the old one. Because I'm going to get confused, friends. I promise that happens. I get confused a lot. Yeah, I'm sure you're all surprised. You're all very surprised. Here we go. So lab 2, all the NetBeans project files. Looks pretty good. All right. So lab 2, done. Commit. And push. All right, so we can close that project. And then I'm going to start up, let's do a new project here. Do classes part 2. we're going to talk about a couple more specific topics about classes, and then we'll look at inheritance as well. So hopefully this may or may not have some new stuff from what you talked about in 1500, but we're going to try and go a little further. And then inheritance, hopefully at least talked about. You might not have done a whole lot with it, so we'll start doing some things with inheritance. Is kind of the goal here. All right, so again, I'm not going to put anything in main yet because I want to go write my classes. So let's go add a class. I'm fond of this bank account example. I think this is kind of fun here. So for bank account, right, we're going to think about what attributes a bank account should have, right? And now there's a trick I learned here, because remember, Java's kind of bad at math, and dealing with doubles is a little bit funky here, right? Because if you add a bunch of doubles together, sometimes you get some really weird rounding happening. So we could round a lot if we wanted to, but the other thing we could do, so when we keep track of someone's balance, if we do an integer, we could say balance in cents. So the balance in number of cents here can be a whole number, because you never have half a cent, right? Best I can tell, that doesn't exist. I mean, maybe you could cut a penny in half, but I don't think it's actually worth half a cent at that point. Right, so if we're tracking your balance in cents, then it's easy to interact with things as a whole number. Now, the problem is this only actually goes up to 2 billion, and if we're doing cents, then that is limited to 20 million. And I don't know about you folks, but I think everybody's got like at least 30 million in the bank, I'm sure. So we probably then want to deal with a larger data type. So we'll be fancy here and call this one a long. Remember, long can be super, super, super big. I believe it was like 5 centillion. So you get millions, you got billions, you got trillions, you got quadrillions, and then you got centillions. And I don't think anybody has a centillion. Actually, it would be quadrillions, right? Because if we're counting in cents here, I don't think anybody has a 10 quadrillion cents. Oh no, with centillion that'd be 10 quadrillion dollars, right? 50 quadrillion. Nope, nobody has that, right? Even our friend Jeff Bezos. Maybe Trosaurus. I don't know. I'm sure that number means something somewhere. I don't do anything at that scale, so I don't know. It's hard for me to think of numbers that large. Like they're just comprehending. Like I get the idea that 1,000, right, is 1,000 ones, and then 1,000,000 is 1,000 thousands, right? That's a lot. And then 1 billion is 1,000 millions, and then 1,000,000,000,000 is 1,000 billions. Like, and then my head just starts to like, whoa, that's just a lot of numbers there. Like the difference between 1,000,000 and 1 billion, it's the same factor as the difference between 1,000 and 1,000,000. But when we talk about people with millions of dollars or people with billions of dollars, that's a real different number there, right? When you're talking about 1,000 million rather than someone who has like 1 million. Oh, centillion, yeah, I don't actually know how to spell things. I'm a terrible speller. But anyway, so we'll do balance in cents, because I think that'll be easiest here. And then how about a string for the owner name, the account owner name, and then maybe a private. We could do a string here maybe for account type. We'll just say type maybe. Type. Private. Oh my goodness. Private string. For type, what else do we need to know about bank accounts? 1,000,000 seconds is 12 days. 1 billion seconds is 31 years. 1,000,000,000,000 seconds. Yeah, so like 1,000 times that is pretty easy. So there's no good like conversion between days and years. So you can't do like it's 12,000 days, but then to think about that in years, the conversion gets a little bit funny, right? The scale of that. So like anytime you're changing that, I don't know. So like if you measured everything in days there, it'd be a little cleaner to see. It goes from 12 days for 1,000,000 seconds to 12,000 days for billion, right? And I think when you change that unit, it messes things up. Yeah, no, there's all sorts of stuff. So anyway, so our bank account, right? Balance and cents, a string for owner name, a string for type. So this is like, is it a checking account? Is it a savings account? Is it a, I don't know, whatever here. We might have better options for this later, but we can look at that another time. All right, so this is pretty good. Oh, goodness. Excuse me, I need more coffee. All right, so now we need some methods here. So again, I'm a fan of letting NetBeans do the work for you. So I'm going to go to right-click, Insert Code, and I'm going to add getters for all of these here for sure. Definitely you can get these values out. If there's no getter, no one has access to it, right? If we don't have a get, then no one using bank account can get it, which is okay. Maybe it is really just a private attribute that we internally need inside the class, but maybe not. All right, so we got our gets here. So if there's no sets, well, you know, some of these might make sense to set here. So I think, can we change the owner maybe? Do you think that's something we could set? You could say, hey, we need to change the name of the owner here. That one probably makes sense to set here. Changing the type, I feel like they make you close the account and open a new one here. And you definitely never set the balance, right? You never go to the bank and say, hey, bank, change my balance to $1,000, please. It doesn't work like that, right? The way that you interact with the bank account is you can deposit money and you can withdraw money. The bank will tell you how much is left. That's kind of their job, right? All right, so we'll have a set owner name. I think this is fine. So you can change the owner's name if you want to. I think that's okay. I don't think they make you change the entire account just to change it, the owner's name. So like, if you're transferring ownership, they might. But like, if you say, hey, by the way, my name legally changed, I think they'll just change it on file. So just that's more like changing your name rather than changing the owner here. But then we need constructors, right? A constructor's job is to give attributes values. So I'm going to insert code. I'm going to insert a constructor. Now, what do we want here? I think the only thing we need is the type, maybe? Right? We have to have a type here when you make a bank account. Right? So you tell me the type here, and we'll assign the type. Again, maybe some checking here. If the type is valid, that's fine. We could do that another time. You know, I figured you guys can compare it to a list. Is it a savings or is it a checking, or tell them no, otherwise they screwed up. And then my balance and cents should start off at 0, right? We want to be explicitly setting defaults here. And then how about my owner name then equals just an empty string. Don't leave this as default, because remember, a default, anything at the reference type will be null. Don't leave the default or you get null, right? Null is real bad here, because then when you try and go use it other places, you might get null reference exceptions and your program will crash. So nulls are ugly. Nulls are bad. Same with nulls. Those mean little nulls there. The GNOL, that's not null. They just sound similar because either my accent or I don't know. All right, that was nulls are bad too. We're like the like dog humanoid race in fantasy. Okay. Anyway, now what if someone knew the owner's name when they made the instance bank account? Well, currently our code would make them create an instance bank account and then call set owner's name. Right. So we want to make our class be a little more user friendly and easier for people to use. So we're going to make another constructor here. So I'm going to say insert code. I'm going to go back to constructor, and we'll take one that has type and owner name. So you give me the owner name and you give me the type. You know, actually, I want those in the other order, though. I want type first, and then I want the owner's name, because the first one asks for type first. So I want to try and keep that, you know, in the same format here. And then we'll take my balance in cents, set that to 0. Now, I feel bad here because I have the same code twice, right? And that's your good rule of thumb. If you have the same code twice, you should feel bad about yourself. It's a pretty good rule of thumb, right? You know, duplicate code is it's not ideal for sure. So what can we do to avoid this? Well, yeah, it turns out we can. There's a couple things we can do to avoid this. So what we want to do here. Let me comment these out here. Don't want to leave those. What we can do is, if you have more than one constructor, right, these are called overloaded methods. You have two methods of the same name, but they have different parameter lists. Right, this is overloading. So I can call my other constructor. Now, with overloaded methods, you just call the name of the method. We can't do that with constructors. So to call an overloaded constructor, we have to say this. So we give it the type, right? It's the same type we just passed through, and then owner name, we're just going to give it blank because I don't know what it is. So this calls the overloaded constructor. Here. Exactly, Mike. Anytime you have the same code twice, you should feel bad about yourself. That's a good rule of thumb. It's not a hard and fast rule. You know, sometimes it makes a little bit of sense to have the same thing in there twice, but generally, you could do better, right? You can do better, right? Okay, so we're going to call that overloaded constructor here. You know, if you guys want like one of those page-a-day inspirational quotes, I can start coming up with all my favorite quotes and put them out there for you. You know, you can do fun stuff like that. There's a bot for Discord. I think it's Discord. Maybe it's even Nightbot. I think it's Nightbot. Hang on, Nightbot. Okay, quote. Let's see. There was someone had a quote that would give you a random Kanye West quote. And I thought it was the coolest feature. You already have a book going. Yeah, quote generate. Remove quotes, editing quotes. Huh. Users can get random quotes. How did you get the Kanye quotes? No, they were good. They were good. I don't know how they did it. Oh, did I spell it? I spelled it wrong is why. Where did it go here? Okay, whatever. I thought it was like a built-in feature. It must have been a cool custom thing. And now I'm a little jealous. They had a really cool quote generator. I don't know. Maybe we can play with that fun feature another time as like a bonus, something or other. So, all right, we'll come back to this. So, overloaded methods here. Now, the other thing we're missing is how you add and subtract money, right? How you deposit money and how you withdraw money, right? So we need methods for that. So we need a public. Now, what type should we return here? Should we give them a true or false result? Should we give them an integer value? Should we, you know, we got a couple options here. So I think last time we talked about classes, we looked at using like a true or false to indicate this was successful or not. Sure, we can do that sort of thing. How about we do longs here? We tell them the new balance here. So we're trying to avoid the decimal places because Java's bad at that. So we're going to use long for cents here. Is what we're going to kind of work with this on. So we'll return a long here. So we'll call this the deposit method. And deposit then, you tell me a long cents to deposit. Sure. Okay, so now definitely we want to sanity check this because we're doing banking here. So first we're going to check if my cents to deposit is greater than 0. Then I can go do this thing, right? If you tell me a negative number, you've done a weird thing and somehow you're taking money out of your account with a deposit action, and that's probably not a good thing here. So I can take my balance in cents and I can just add the cents to deposit, and then I can return, actually either way then when we're done, we can return the balance in cents. Right, so we'll tell you the new balance. So if you gave me a positive number, let's go add it and we'll give you back a balance here. Fantastic. Again, probably we could do some really cool fancy stuff like let's write down the teller's name for logging this in our transaction list, and I don't know what other stuff banks actually do, but I know they've got all sorts of tracking things, like they can go look through every deposit you've ever done and see who initiated it, that sort of thing. Sure, but that's probably beyond here. So now the problem here is when people want to use deposit, they have to give me a long value. So if I were to go make a bank account here, so we'll go make, let's call this a savings, I'm sorry, a bank account. We'll call it savings equals a new bank account. And the type here will be savings, and then the owner's name is going to be Eric, right? Because we know what those are. And if I want to savings.deposit here, if I want to deposit, let's add 100 cents here. Okay, easy, no problem. This worked out. So remember, integers fit inside of longs. So not too big of a deal here to make this long. So if I don't give them a long value, Java will still take it because a smaller type will fit inside of a larger type. Okay, but if I were to do some sort of like keyboard input and say, hey, user, how much money do you want to deposit here? I'd have to go do a bunch of conversion stuff. So what we can do to make bank account more friendly is we can add an overloaded method here. We'll call this deposit. We'll give it a string cents to deposit. So we're going to overload the deposit to make it easy for people to use. So when we let people interact with us in this abstract manner, when we give them that public application or programming, oh my goodness, application programming interface, the API, right? We give them all of our public methods. We're going to give them ones that are easy to use. Right? If you come back to our regular code and we look at some of these things here, like what are some of the methods that had a lot of those overloads, like math.round. Math can round doubles or floats. Okay, that one's not super interesting. How about integer parse? No, that only takes strings. That one's not all that interesting. There's some in here that have a lot of overloads. That's what it is. So system out.println. Nope, not even println. I'm not thinking of any off the top of my head, but a lot of their functions will take more than one type here. So we're going to do that same idea. So we want to make it easy to use. So all we need to do then is we're just going to call deposit given, we're going to say long.parseLong given the cents to deposit. So we'll do the parsing for you. If you want to give me a string, sure, we'll do the parsing and then try and deposit it with our method here. So we need, and now it's yelling because it didn't return anything, we need to return that. Now this might crash, right, if you don't give me a valid string. So we got that's okay. That's on you because you give me a bad string. But we'll try and convert it here and try and deposit. Okay, sure. But now how about a way to withdraw? So we need a public. Now, long, we probably will just give them back the money that they've withdrawn, right? And then if it fails, give them back a 0 maybe. I don't know. A withdraw, given a long cents to withdraw. Now, is it withdraw or withdrawal? So, like, the withdrawal is the thing you did, but withdraw is the action or the verb? I hate English. I don't know why it's so complex, but I guess other languages are hard too, maybe. But I think it's just withdraw. You make a withdrawal, but you withdraw money? Sure. So we need to check first, right? So if our cents to withdraw is greater than 0, and our cents to withdraw is less than or equal to our balance in cents. Right? You can't take out more money than you have. The bank will make sure of that. So if it's positive and less than our balance, we're good to go here. We'll take our balance minus equals the cents to withdraw. Right? And then we can return. I don't know if we want to return that there. Maybe we return it here. Return the cents to withdraw here, otherwise we return 0, maybe? I think that makes sense, because if they gave me a bad number, we're just going to get, hey, here's your 0 pennies. Or if they tried to take out too much, we'll say, nope, here's your 0 pennies, try again. Again, not the most helpful error messages or anything here, but we got something happening. And then we're going to do a similar thing here with withdraw, where we overload. So this will be withdraw, given a string for cents to withdraw. And then we'll just call withdraw, parsing the sense to withdraw. Again, just trying to give it a friendly option here so that when I'm using my bank account, now I can take savings dot. Now if I type withdraw, I've got a string option or a long option. Right? Either one I want to give to my methods here, my class here, we can take care of it. Or deposit, right? String or long. You'll take either one. We could do doubles and floats. The problem with doing doubles and floats is there might be decimal values, and they're going to lose any decimal places. Right? And that bad stuff could happen, right? If you try and deposit fractions of pennies. Or we just tell them there is no such thing as half a penny, so why'd you try and do that? So maybe we can do that one. We can overload it again, right? Let's add another long, so this will be withdraw given, let's say a double sense to withdraw here. So if they give me fractions of pennies, we're going to pretend they don't exist. How about that? Right? Does that make sense? So this will, it's another overload, withdraw, and then this will ignore any decimal. Okay, I think we can do that. So I'm going to call my own withdraw method here, and then I'm going to give it, I want to cast this as a type of long, my sense to withdraw. So we're going to say, oh, hey, by the way, Java, I know it's a double, but do me a favor, treat it here as a long. We'll go cast it. Yeah, take those fractional pennies, right? From Office Space. Just make sure you don't code it wrong. And then we return this value, right? So when you cast to something that can't have decimal places, the decimal places just go away. Now, bad things might happen here because the maxes, I think, are different. So max value of Java double is something big, right? What is, why? All right, oh yeah, double dot max value. What is the double dot max value? Let's see. Let's go check that real quick. Let's go see what that is. We'll print it out. So we want double dot max value. Oh, double max value. And then we'll print out, how about long dot max value? Nope, max value. Let's see what we get here. Oh, this E notation. So I think that means this is a lot bigger here, right? So, but again, are you really going to deal with more than so many centillion cents? Probably not. Maybe we want to be careful here. I guess we could be careful first here. So where's our withdraw? Where's our withdraw here? I guess, so we're converting it to a long, so it's only going to return the sense that they withdrew. So if they try and withdraw, say, what is that, some, with hundreds of thousands, 300 zeros here, we're going to convert it to a long and it's not going to work. And then we'll just give them what they actually did take out. Maybe that's okay. I don't know. Again, that's a really large number, so probably not a big deal here. But we could do some checking here. Check that the double isn't larger than the max long. Sure, we could do that sort of thing. And again, we could overload deposit as well. Same idea here if we wanted. But sure, we can do it real quick, right? That was pretty quick. So we'll do another public long deposit. Given a double sent to deposit, and we'll just convert. We'll return deposit given a long of the sent to deposit. We'll do some casting here. This one we might want to check here. So we'll say if my sent to deposit is greater than long dot max value. No, max value. Come on. Know what I want to type here. Max, nope, max value, there we go. Or how about if it's not? If it's not greater, then we can return that. Otherwise, we return 0. So let us do that. No. If sense to deposit is greater than the long max value. No, so we want less than or equal to the long max value. Let's go deposit it. Otherwise, so feel like this is probably kind of safe. What do you think? I don't know. Let's see what we get. So let's have some fun with it. Let's try it. So let's take our deposit here. Let's have this store this as a long for a result. Savings.deposit, double.max value. And then let's print out the you deposited plus result cents. Give that a run. And we deposited 0 cents. Okay, I think it works out okay. Right, what do you think? You think we're okay? That makes sense for kind of overloading some of these methods here. So we're giving them options, right? And then we get to control what happens here. Again, you don't have to have overloaded methods, but what we're trying to do is make the class easier to interact with. So we have different options for whoever's using my class that they can use these convenience methods because we've already done this conversion stuff for them. You know, I never saw Superman 3. I didn't know stealing fractional pennies was a subplot. Is that like the villain? I mean, no spoilers, obviously, but I don't know. It seems like a weird thing for a big villain to do in a Superman movie, to steal fractional pennies. But sure, why not? All right, how do we feel so far? So bank account, we've got constructors that call other constructors with this operator, and then we've got methods that call other overloaded methods here. Oh, it's one of the henchmen? Okay. All right, and now the last thing we want to do is we want to give you a nice way to represent this as a string here. Not that the main villain spot's much better. No, they're not really. Yeah, we can talk more about that in inheritance once we get there. So I think, let me double check. I think we got through everything we wanted to. I actually got the book here. Look at that. Let me give it a quick skim again here. This is the rest of chapter 7. Classes, methods. Oh, static. There we go. Static methods. That's the other thing we wanted to look at here. So all of these values so far have been private instance attributes. So every instance of bank account gets a new one here. The next thing we can do here is we can make static values, and a static value belongs to the class, not the instance. So like the definition level. So when some of these things we've been using here, like integer.parseInt, this is a static method because you don't need an instance of integer to do this with. Right? We just say, hey, class name.method here. So classes can have static methods as well. So we're going to have a private int for next count number, and this is private static int next account number equals 1. So we're going to be tracking these account numbers here. So every time we make a bank account, we'll generate an account number. So we'll have a private int for account number. So we need to assign the number as well. And then what we're going to do is we're going to make a method here that's going to track that for us. Maybe we don't even need a method for it. We just have it as an attribute. So we'll say account number, or no, this was number, right, is going to equal my next account number plus plus. So next account number is tracked and stored one time at the class definition level. I know that's going to sound a little funny here. So static values are stored at the class level, not the instance level. Right, so when you make an instance of bank account, I can have 15 different bank accounts that each have their own long for balance, string for name, string for type, and now int for number. There's only one next account number to find. And that's at where bank account itself is loaded into memory. The definition, the blueprint of this class is loaded into memory. Anything static gets loaded there. So what I can use it, I can access it from within my class here. But it's all shared among all the accounts. So then we need a get account number here. So let's go and add the get here. We'll insert a getter for regular number, get number. Okay. So then as I make bank accounts here, this is bank account number savings dot get number. Get number. Great. And then let's make a new bank account. Call this one the checking account. Equals a new bank account. Again, we'll just give it maybe just a type of checking. Why not? We don't know who the owner is right now. And then we'll print out the bank account number of checking. Okay, give that one a run. So we should get the first one will be account 1, the next one will be account 2. Because they keep getting updated one at a time. Every time this constructor gets called, we take the account number and then we add 1 to it. So we can have something that's defined and shared among all the classes here. Right? Other things that you might have a public static final int for like a routing number here. Routing number, and that would be like, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9 or something. Right? Your bank's routing number is shared among all of the bank accounts here. Every bank account shares the same routing number, and this is a final value that never changes. Right? So when you go put in the routing number here for like electronic payments or ACH payments, that sort of thing, or direct deposits, every account has the exact same one, and this can be public here. Anyone can go check what the bank account routing number is. Right? So the routing number is, right, and then checking dot. Now, it doesn't exist on checking, right? Checking is an instance of bank account. I can use all the methods here, but I don't have the routing number because routing number doesn't belong to the instance of bank account. Routing number belongs to bank account. So it's bank account dot routing number. Right? So routing number is a part of the class definition. We get at it like class name dot, just like integer.parseInt. Right? That sort of thing was class name, and then you can have static methods. This is just a static value. I'm in class too late. No smoothies. Right, so this is a static attribute. You can have static methods. It doesn't really make sense for bank account to have one right now. I don't know, we'd have to think of probably a better example for static methods, but this is pretty good. So these are shared among all of the instances because it's defined at the class level. Right? So whether or not it's something private that we're just using internally or it's something else here. Now this is not really great here because like this only exists in memory, and every time I restart the program I'm going to go back to 1. You know, really in real life we pull this out of a database somewhere, right? Come from a database value or something like that. But you know, again, we don't care too much about that right now, and we don't have any ways to do that. So, and we'll get to databases later on in the semester. But for now, sure, we'll just assume it's 1. Okay? All right, so we come back here. So this is classes part 2. You folks are doing great. Commit that. So then we're going to move on to inheritance, and then we'll talk about the next lab in a little bit. My coffee cup is almost empty. All right, there was a little more than I thought. I forgot how big this mug is. Now it's empty. I'm going to go get some more coffee. We'll put some music on. We'll come back in 10 minutes, and then we'll pick up inheritance, and we'll talk about the next lab. And then next week, we're going to finish up chapters 8, 9, and 10, right, which put us through, I don't remember the titles up in here. This is why it's all written down. Interfaces and some more object-oriented programming skills. So we'll finish up inheritance probably next week, and then 9 and 10 are a little shorter. We don't go too deep with interfaces from chapter 9, but we don't talk about them. You'll use them a lot in the data structures course, 2353, if you do go on and take that one. And then our more object-oriented programming skills, that chapter 10 just has some good extra stuff in it, which is awesome. That's like way back in here. There's a lot of words in these books here, right? A lot of words. Yeah, cool. All right, let's do that, folks. Let's take 10, and we'll come back, get your coffee, and we'll go from there. We'll put on break time. Puts us at, what, 11:07, I think? 11:07? And we go from there. Hey folks, welcome on back. Merlin came to say hi. Say hi, Merlin. Merlin, say hi. You don't want to say hi to everybody? Oh, come on. Just stay in my lap here, though. Buddy, you're getting kind of big. He used to fit better when he was a kitten. He's turning 1 in February. I can't believe it. But he would like climb up on my shoulders and stuff. But he's a good little kitty. Yes. You gotta say hi to everybody, though. You can't just stay here on my lap. It's hard to type with you here. It's hard to type. Yeah, I know. My hands got to go like right here, and then you keep moving my hands. All right, so we're going to talk a little bit about inheritance, and then we'll get into the lab and start practicing some of that. What do you folks think? Merlin Shady Crow says hi. You want to say hi to Shady Crows? And he barely ever meows, too. He's like the quietest cat I've ever had. He's really funny. Hi. Hi. Okay. So I get for leaving my office door open here when I went to get my coffee. Snuck in. Yes. Okay. Can you just lay quietly while I type? I don't know how well this is going to work. We'll try it. Okay, so this was classes part 2, so let's start up a new project here for, let's do inheritance part 1. Yeah, don't bite me. All right. So when it comes to inheritance, the idea here is this is actually generally a fundamental of object-oriented programming, and the idea is we don't want to reinvent the wheel, right? If there's a class that does something, and I want everything that it does, but then I want to like specialize it a little bit, we might be able to take advantage of inheritance. That's one possibility. So it lets us kind of build classes in a way that we take advantage of stuff that's already written, and then we can make specialized versions of it from there. You can't climb up on the keyboard. No, don't climb on the keyboard. Let's say hi, everybody. Say hi. Oh, are you grumpy? Why are you grumpy? All right. Let's go make a class here. So we'll do some boring ones. It's a pretty classic example. So let's do Polygon. So a class for Polygon here then. Things about polygons. Polygons have a number of sides. And then we're going to track an array list of integer for side lengths. Okay, and then yeah, let's go import our array list, please. And then we want to add so we want a getter for number of sides. And we want a int for get side length, but you need to tell me the side index, right, of what side index you want the length of, right? And then we can just return my side lengths dot get side lengths dot get the side index. We'll get that value back out. All right, and then we also need a constructor. So if you tell me if you want to make a polygon, you need to tell me how many sides this polygon has here. And then what we're going to do is we're going to make side lengths be a new array list, right, of type integer, right? And then what I need to go do is I need to go add zeros for all of those because I don't know what the lengths are, but I want there to be values existing at those indexes. So remember, with array lists, we don't get default values. Like with an array, you say, hey, I want an array of size 10, you'll get 10 zeros inside of that. With array list, we don't do that. Now we can tell it side lengths here. This is an optional, so this will pre-size the array list. It doesn't give us default values, but it'll pre-size the array list so that it doesn't have to go through and do the growing process. Again, don't worry too much about that. Whether or not you include it doesn't matter too much for our purposes, and we're not going to notice that the slowdown at all. But now I can say for side index 0, side index is less than number of sides, side index plus plus. And again, I know most people just use I. I don't like I if I can help it. I'd rather use something meaningful rather than I. That's just me. So we'll take our side length then, and we're going to add a 0. So we'll add that many zeros. So for however many sides you have, I'm going to add a bunch of zeros here. Right? Excuse me. right? And then we need a public, probably a void here for set side length, given an int for the side index and an int for the length. So you tell me which side and how long it is, and I'll go set it. I'll take my side lengths, and I'll call set. And set, we can say, okay, what index and what length? We'll go set that index to that length. Great. Now, these might crash, so we're not doing a very good job of being defensive here. Avoid crashing. You know, if it's going to crash, though, right, it's whoever called it gave us a bad index. And really, we would just give, we'd crash too. So I don't think nothing too defensive here. If needed, it will just crash. Right? I think that's probably more fair, because if you try and get an index that doesn't exist or set an index that doesn't exist, it just, and it fails. So I think we're okay there. Now it is telling us, and this is kind of cool, that the number of sides can be final. If it only ever gets set once, we can make it a final variable so that it can't be changed accidentally outside of that. Right, so that's one approach, and it'll always suggest that if it notices you're only setting it one time. Right, it's trying to be helpful here, and protecting yourself. And sometimes that is correct. You want it to be set one time. Like once you have a polygon, it's kind of hard to change the number of sides of that polygon. You really kind of have to draw a new one, essentially. I guess you could really add to it, right? Because it doesn't necessarily have to be closed, but that's okay. And then the other thing a polygon can do, right, is we can get the perimeter of our polygon. So we'll have a public int get perimeter. Perimeter. Right, so we're going to have an int for perimeter. Perimeter starts off at 0. And then we'll say for int length in side lengths, let's take perimeter plus equals the length. When we're done, we'll return the length, or return the perimeter. That one. Perimeter. Perimeter. Why did it not suggest that? Perimeter? It looks like it's spelled wrong, but that's okay. That's what Polygon can do. Okay, this one pretty straightforward for a class. Not a whole lot of interesting stuff here, but we can get a perimeter out. We can set side lengths, we can get side lengths, that sort of thing. Now, what we can do is, once I have all of this defined, if I want to go make a special version of this, if I want to take everything that make it like a particular kind of polygon here, I don't want to reinvent the wheel. I don't want to have to redo all of this here. So what I'm going to do is I'm going to add a new class here. Now, how about like a rectangle here? And with the rectangle class, we're going to use a keyword here. We're going to say rectangle extends polygon. So when we extend polygon, that means it creates an is-a relationship, right? A rectangle is a type of polygon. And we're kind of familiar with inheritance, right? It kind of builds this hierarchical structure. If you think back to biology class, right? There's the kingdom, phylum, class, order, family, genus, species. I don't know why that's in my head. Apparently it's just stuck there forever now. But right, you get this idea that there's mammals. So mammals is the phylum or the class? I don't actually know. Mammal kingdom phylum? I don't know. Maybe that'll come up with it. What is it here? Class. Okay, class Mammalia. So kingdom, phylum, class. So we're in the class Mammalia. Right? So all mammals can be defined, right, as a mammal. But then there are special types of mammals, right? There are different groups within that hierarchy. So cats and dogs are different kinds of mammals. Humans and dogs are different kinds of mammals, right? So then you further break down, but we all share similar attributes of mammals, right? So things that are common of mammals, right? That we're warm-blooded and we give live birth, and it's been a while since I took biology, but that sort of thing. But then each individual type of mammal, each specialized version of mammal has its own set of attributes, right? Like, and hopefully I think that one's pretty obvious. So we're getting that same kind of relationship. So polygon is the base class or the super class or the parent class. You got all sorts of fun ways of defining that. So it's a parent class, the super class, or the base class. So polygon is that, right? And then rectangle is the child class, the subclass, or the derived class. And you can use any sets of these pairs. I like super and sub because super, we're going to find out, is a keyword in Java that means something here. And right now it's lit up real red here, and it's saying, hey, Polygon in class Polygon cannot be applied to given types. Required int, found no arguments. Actual and formal arguments lists differ in length. It seems really weird, but what happened here, I think we actually probably skipped over this when we talked about classes. When you write a class in Java, Java will actually give you a constructor method, right? It writes one for you automatically. As soon as you go write one, you lose that default constructor. So the only constructor that's available needs a number of sides. And if we are a type of Polygon, we have to call our parent class or superclass constructor. So it's yelling at us here because it's required to call the superclass constructor. Absolutely must happen because you can't make an instance of this without it here. So if we look back at, say, like bank account, this constructor needs a string for type. We could also, if we wanted to, have a bank account that takes no arguments here. We call this with just like empty quotes and empty quotes or something. This is probably not good here. But then I can make a bank account with a default constructor or a no argument constructor here. Well, we don't want that, right? So it depends on your class. If you want your class to have one, great. If you don't want your class to have one, that's fine too. So if we need to call that constructor, then we need our own constructor. So public rectangle. So the first thing you have to do in a subclass constructor is to call the parent class or the superclass constructor. So if there is a default constructor, that one happens automatically. So if the superclass has a default or no argument constructor, will get called, ran automatically. So in our case, it's not. So the first thing we need to do is we need to say super. So super is the keyword that says, hey, go to the superclass. And now Polygon needs to know the number of sides. A rectangle always has 4 sides. This is the Polygon constructor. Tells it 4 sides, right? Because rectangles always have 4 sides. So that's our constructor here. Super 4. Right? Pretty straightforward there. Now, other cool things about rectangles, right? Their lengths and widths always need to match. That's a little bit of a problem here because with Polygon, you can set individual side lengths differently here. Well, that's not cool, right? So what we need to do then is we need to change the behavior of set side length. So when you extend a class, when you have this inheritance relationship, you can change the behavior of that method here. So we're going to use this @override tag here. So @override is just a little annotation. It lets Java do some checking for us to make sure that we're actually changing the behavior of my parent class method here. So this is set side length, given an int for side index and an int for length. So this is optional, but allows for compiler checking. So it makes sure that we typed it right. So if I were to say, hey, I want to change the behavior of set side length, but I typoed it here, because sometimes I do HT, it's perfectly fine letting me write this method. It's not overriding anything here. So if I try and add the @override tag here, it's going to tell me, hey, it doesn't override anything. You did something wrong. So it gives you that compiler checking to say, hey, you wanted to override something, but you're not actually doing it. You did the wrong thing here. Okay, so I'll leave that commented. You can see like it will check for typos, helps avoid typos, that sort of thing. So when we call set side length here, what we want to do, you can say if side length is side index is equal to 0 or side index is equal to 2. Let's then set both of them, right? Now, a weird thing is happening because set side length is my method. When you go through inheritance, anything that is private, you don't have access to. So I can't go change these side lengths directly. I can't say side lengths right? Lengths, it doesn't exist. Side lengths, I don't have access to it here. So I have to go through the methods just like everyone else does in Polygon to get access to this. So to do that, I need to go to my superclass, super.setSideLength. And I'm going to say, hey, set 0 to the length and super.set2 to the length. So if you tell me you want to set 0 or 2, I'm going to set them both because they're fixed here. Well, the superclass version. Right, so super., we'll call the superclass version here because we're saying change the behavior. So if someone has a rectangle, they can't use the Polygon version of setSideLength. They have to use my version. And really, if it's not a 0 or 2, and it must be a 1 or a 3 here, 1 or 3, we'll set the side lengths. Or maybe, you know, just in case they did a dumb thing here, maybe we can go do some checking. Like if they tried to set, you know, 4 or 7 or 22 or something, maybe we can pair it up again like that. So if it was 0 or 2, set 0 and 2. If it was 1 or 3, set both 1 and 3. So that way you're setting the lengths together and you're setting the widths together. Always one way or the other. Does that make sense? So we're adding some new behavior here. We're changing the behavior of my parent class to make sure we're protecting the integrity of my class. If you can set one length but not the other length, you're no longer a rectangle. Right? So a rectangle would be in a bad shape here. All right, the other thing a rectangle can do, which is cool, is it can calculate area. Right? To do that, we're going to return get side length of 0 times get side length of 1. And actually, you don't even need the super word here because you have a method named get side length. Right? When you are an instance of the parent class, you get all of the public methods. So I have a method named get side length. The reason why we have to use super here is if I just call set side length, it would run my set side length. And then I'd be stuck in an infinite loop. It would do it over and 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 over. We would be stuck. So I need to specifically say I want the superclass version here. In this case, there is no version that Rectangle defines. Rectangle doesn't have a get side length method directly. It inherits it from Polygon. Okay. It's going to take a little while. We got to talk about it again. This is why we kind of introduce it in 1500. We come back to it again here, and we'll come back to this again next week. All right, so I think we're due to cut out here, and then we can talk about our lab exercise. We can actually practice some of this inheritance, and then we can go. Then we can call it a day. What do you think? We'll come back to this more on Tuesday next week to kind of wrap up this, and then we'll finish out the other interfaces and more object-oriented programming tools and techniques next Thursday. Think that sounds good? Oh, excuse me. Okay. All right, cool. So for labs, let me go pull up a GitHub link for us real quick. Man, this coffee's good, but it's making me burpy. That's super weird. All right, so this will be lab 4. For inheritance. So we'll be due next week, 10 a.m. Say 10 points. I think we're doing 10 points for all the labs, right? I think that's what it is. Put that in labs. Nope, labs. There we go. In the labs category, text submission, submit the URL to the feedback, pull request. Go. I don't know why you always have to click the sign in button. Like most things can recognize that you're already signed in and or attempt to sign you in. This one doesn't do that. I don't know why. Uh-oh. Bad gateway. Okay, fine. It went away. It's 2151, winter 2022, lab 4. Let's do our Java template. Feedback pull requests. Okay, Great. So there's your link for that. So we're going to write a class item that has attributes, private attributes for name and price and quantity. Include get and set methods. I don't know, for all of them, I think. All the attributes. I think that's fine because you can change the name, you can change the quantity, you can change the price. Name probably doesn't change much, but that's fine. We'll just say you can include all of them. Add a method for get total price that returns the price times the quantity. And then write a class taxable item that extends item. Include an attribute for tax rate. So we need to include a constructor too. Include a constructor that accepts values for all the attributes. So if we have a constructor, we're going to have to call that constructor. Right? So we'll need to have a constructor that accepts tax rate, add get and set for tax rate. And then we're going to override the get total price to include the tax owed, right? So that's the tax rate times the total price, right? So we add, right? So if the tax rate's 6%, that's 0.06 for Michigan sales tax. 0.06 times the total price, it gets added to the original total price. Okay. So we're just trying a pretty basic one here, and then I think that's okay. We could do more, but I think this is fine. So we're running a little short on time here, so this should be like a 20-minute exercise or so to write 2 little classes. Okay, just to practice. We'll do more when we come back on next Tuesday with some more inheritance part 1. How about that? Call that inheritance part 1. Okay, so we got item and we have taxable item. Actually, is that the example in the book? Really, I guess I should have looked at that because now I'm forgetting. I think the book might even do that. Let's see. Inheritance. Oh no, they don't, right? What do they go through? Yeah, they have book and they have product. That's fine. Product, software. Okay, yeah, so we're fine. We're fine. I think we'll be okay. I don't think they do anything with taxes here. Not quite so easy to copy paste, right? Cool. So we'll finish up chapter 8 on Tuesday, and we can go from there. So I'll post the quiz for chapter 7, just chapter 7 today, and then next week we'll finish up chapter 8, and then we'll get into chapters 9 and 10 as well. Okay. Don't forget, Project Zero is coming up due before you know it. Right, February 3rd is coming up due. No, that shows all. I learned that last time, and that was it pulls up like all my notifications. So February 3rd, right, coming up before you know it. So do start on that. Happy to answer questions, get you pointed in the right direction. Anything you need on those, just let me know. Okay, folks? All right, so we'll go ahead and end stream here. Thanks for hanging out online with us. I'll post the recordings. Don't forget they all go to this content lecture archive, or you can go subscribe to my YouTube channel, and they're on a playlist in YouTube as well. So hopefully you're going to be easy to find for you, and we can go from there. All right, folks, I'll be around on Discord. If you have any questions, feel free to shoot me a message, email me, text me, call me. I'm happy to help you out and get you going, okay? All right, everybody, enjoy your coffee. Oh, yes, which quiz is due tonight? We have the chapters 11 and 15, right, from our review? Yeah, thank you for that reminder. This one's due tonight as well, 11:59 p.m. Thanks, Mike. Mike's looking out for you, folks, right? Don't forget to grab those. So I think everything shows up in the calendar widget here, but not the update widget, which is super weird. So someone will show me, like, updates will show you if you have missing quizzes, but not missing assignments, where like I usually look at this calendar view and see what stuff is due when. So just having the lectures in there, is that useful, or is that just like create more cruft that you just are going to ignore in the calendar view? Because I could take those back out. I don't know. Some people use that calendar view and it's helpful, but so I thought I'd put them in. But okay, cool. All right, folks. If there's anything else I can do, let me know. If not, have a great weekend, and I'll see you Tuesday.